Yeah.
Okay, good afternoon, class. So let's start the tutorial session this week. Now, this time in this example sheet, there are quite a lot of questions and we cover quite a lot of content of the course materials, and I'm not going to go through every one of them. I don't have enough time. So maybe we can go backward from the most recent contents. For example, question number 9, which is a typical question related to the properties of point estimation. So just spend a little time try to work on this question. And if you have already completed this, then you may try the other questions. And let me know if you encounter any problem. Okay, maybe I explain a little bit about the walkthrough to this question so that we can move on to the next question. Now, this is a typical question about how we can find the properties of an estimator. Now, whenever we have an estimator, there are two quantities that we are interested about its behavior. The first one is the bias. The bias of an estimator, by definition, it is equal to the expected value of the estimator minus the parameter that we want to estimate. Okay? So essentially, it means the deviation between the average value of the estimate, on average, what we will obtain as our estimate, compared to what actually we want to estimate. And we call this the bias. So according to this question, we have the estimator given in the form of Ks bar, K multiplied to a sample mean. So it is a multiple of the sample mean. And according to different distribution, we will have a different way to find this expected value. In general, when we have a sample, we have a random sample, the expected value of the sample mean is equal to the population mean. This is a general property of a random sample. If you have a random sample, you determine the sample mean. The expected value of the sample mean will be equal to the population mean. And it depends on what population from which the sample was drawn. In this example, the population is uniform, within 0 to the unknown parameter theta. So we need to make use of the property of the uniform distribution that probably you should have already learned before. In general, for a uniform distribution range from A to B, the population mean is at the midpoint of the interval. And the variance is equal to b minus a squared divided by 12. So this is the property of a uniform distribution. So I'm making use of this, the population mean for this uniform distribution with a equal to 0, b equal to theta. It is equal to half theta. So this is the bias. But we are asked to find the value of k such that the estimator theta hat is unbiased. So need k such that this is equal to 0. We need to find the value of k such that the bias is 0. That's the meaning of unbiased. An unbiased estimator is an estimator with 0 bias. So we find that from this expression, we know that setting k equal to 2 will result into an unbiased estimator. So that our unbiased estimator is equal to 2 multiplied to the sample mean. We use 2 multiplied to the sample mean to estimate the upper bound of the interval. That will be an unbiased estimation. Okay? Now next, we are asked to find the variance of it. Now, variance of the this unbiased estimator is equal to the variance of 2 multiplied to the sample mean. Then we can make use of the property of variance. We first extract the constant multiplier out of the variance sign. This is the general property of variance. You have a multiplier in this inside the variance. You extract the constant multiplier out of the variance sign, you need to take the square of it. Now how can we find the variance of the sample mean? Again, we have another formula for a random sample. For a random sample, the expected value of sample mean is equal to population mean, as I mentioned before, and the variance of the sample mean will be equal to the population variance divided by the sample size. This is a general property of a random sample. So this will be equal to 4 multiplied to sigma square over n. But what is sigma square? It is the population variance. So it depends on what population from which the sample was drawn. It is the uniform distribution. So from the formula, according to the uniform distribution, the population variance can be determined using this formula. Substitute a equal to 0, b equal to theta, we can get theta squared divided by 12. So this is the variance of this estimator. And the question also asks us the behavior of this when n is large. And we can see that when n tends to infinity, the denominator tends to a very large number, and the numerator is just square of theta. So eventually, the variance will converge to 0. So to answer such kind of question, you need to first understand the definition of the bias, and also the property of the variance, and the property of random sample. The sampling distribution of the statistic from the random sample. In particular, expected value of the sample mean equal to population mean. Variance of the sample mean equal to the population variance divided by the sample size. This is the general property of random sample. And also, you need to be familiar with the property of finding how to find the formula, based on the formula, how to find the population mean and population variance of a particular distribution. So you need to be familiar with all this in order to tackle such kind of problem. Okay? So these are some essential knowledge that you need to acquire in order to solve this problem. Okay? Is there any question? Now, Using all this, the same technique, you can try to work on question number 8 and question number 10 later. But now here, I would like you to try to work on question number 7, which is a calculation of some probability related to the sample variance. system. We have this relation. This is the definition of the sample variance. Okay, actually I didn't expect you can get the exact answer at the moment because it requires to use a function in R. But at least you need to know how to get this number and where we should start. Now this is a problem about a random sample from the normal distribution. So according to the sampling distribution of the statistics from a normal population, these are the general properties, and these are very important properties because we always have samples from normal distribution. Whenever you have a random sample from the normal distribution, the sample mean will follow the normal distribution with mean mu and variance equal to sigma squared over n. And another property is that is related to the sample variance. N minus 1 multiplied with the sample variance, which is the numerator of this term here, divided by the population variance sigma squared, will follow a chi-square distribution with degree of freedom n minus 1. We call this parameter the degrees of freedom. Now in this question, we are interested in a probability related to the sample variance. So we need to make use of this property. And we know that if you scale the sample variance, this will follow the chi-square. And we know how to compute the chi-square probability at least by using R. So the approach to solve this problem in part 1, probability S squared lie between 25 and 60. We are asked to find this probability. Now this probability S squared, you need to find a distribution, a nice distribution that related to S squared based on this. So we substitute n and sigma squared in this. According to the question, n is equal to 10. Sigma squared is equal to 36. This is sigma squared, right? So that n minus 1 s squared over sigma squared is equal to 9s squared over 36 equal to s squared over 4. And this will be distributed as chi-squared 9 because n minus 1 is equal to 9 according to this problem. So in other words, in this problem, if you take a quarter of the sample variance, it will follow a chi-square distribution with degrees of freedom 9. And therefore, it suggests that this probability will be the same as this. We divide all this number by 4. The reason is that we can make this random variable as a random variable follow the nice distribution here, which is chi-square 9. Okay. So this is how we try to tackle this problem. The probability that we want to compute is a probability in terms of the sample variance. So you need to find out the distribution of the sample variance, or at least how to transform the sample variance so that we can have a nice distribution. So we make use of the property of the normal sample. We know that this kind of transformation will make the sample variance a chi-square random variable. And then eventually this probability will be written in terms of the CDF of the chi-square distribution. Then you can use the R to find these probabilities. Okay? Any question? Now similarly, you can try to work on part 2 to determine the sample size such that this will be equal to 0.9, also using R, by try and error, putting different value of n to compute this probability. So I'm not going to go through the details. You can find the details in the solution. But the main idea is this one. How we can transform the sample variance so that it will follow a normal distribution. This is the key idea. Now let's try to work on one last question. Question number question number 4. Oh, you mean M is M is also known? Because we cannot differentiate. Because M is small. M is small. This is not good. So for each of this kind of problem, M is assumed to be the one. So you want to have just P. If you want to know what this means, then you need to use the difference power relation. So you use the relation of n get n to to see what it's equal to zero, when it's equal to 1, when it's smaller than 1, you will see when it's increasing, when it's increasing, so this gives us a function to use the part of the function, because you have a lot of functions. So we don't have time, so maybe I just briefly explain a few key points for this kind of question. Now, it is a typical question related to a normal sample. Again, we have normal samples from this normal distribution. So we have a normal sample. As I mentioned before, whenever you have a random sample from the normal distribution, then we have this property on the sampling distribution of the sample mean, and also the sampling distribution of sample variance. Now in this question, we are asked about two random samples. How likely that the absolute distance between the two sample means is no greater than 0.3. So in other words, it is a question related to the sample mean. So this time, we need to make use of this property. Now notice that there are two samples here from the same population. We have a sample of size 10 from this distribution. We have another sample of size 15 from this distribution. To distinguish them, I use symbols x and y. So make use of the property of the sample mean. We know that the sample mean of the x sample will follow normal distribution with mean equal to mu, variance equal to the population variance divided by the sample size, which is 10. And the sample mean of the y sample follow a normal distribution with mean also the mu and variance equal to the population variance divided by the sample size. Okay? Because we have different sample size, so the variance will become different. Now we have the two sample means. We are asked to find this probability. The absolute distance between these two sample mean differ by more than 0.3. We are asked to find this probability. So you need to make use of this result to find out how to compute this probability. So we need to further find out the distribution of the difference between these two sample means. So the distribution of the difference this is also based on the property of normal distribution. You have two normal random variables. This is a normal random variable. This is also a normal random variable. If they are independent, because they are from independent samples, independent normal random variable add together will have a distribution also normal. And the mean will be obtained by, you have a difference of them, the mean will be also equal to the difference of them, which is equal to 20 minus 20. The mean of x10 minus the mean of y bar 15. 20 minus 20. 20 minus 20. And the variance, don't take the difference of the variance. We are also adding up the variance of them, no matter this is minus or addition. So we need to add the variance of this to this. So this is how we can find the distribution of the sum or the difference between two normal random variables. Difference of the mean, but the variance is aggregate. So if it will be normal with mean 0, and the variance, the sum of this will become half. So finally, you can evaluate this probability, which is equal to 1 minus the probability. This absolute distance is no greater than 0.3, and it can be computed by using this. This is the formula. How we can, if you have a normal random variable, we standardize it so that we can make use of the CDF of the standard normal. So eventually you can use the standard normal distribution table, or using R, you can get the numerical answer. You can refer the details. For the detail, you can refer to the solution. Okay? But I just want to explain the flow of this kind of problem, how to tackle this kind of problem. We start with a problem. We are asked to find the probability related to the difference between two sample means from the normal samples. So you need to make use of the property of the normal samples. And then eventually, step by step, find out the distribution of the difference between these two sample means. And then next step is to find the probability using what you learn from the normal distribution. Okay? So this is the flow, how we can tackle this kind of problem. Okay? Is there any question? Now I know that there are quite a lot of content of this in this website, and also a lot of materials in the lecture notes and videos.